Good morning, this is Kasturi Day. Today I am again going to discuss the question answers of physical quantities and measurements, okay, according to ICSE syllabus class 8. Today I am going to start with the last question which I have ended yesterday, in my last video, okay. So the 19th number question, the diagram given below shows a body of flotation in three different liquids A, B and C at different levels. In which liquid, first question, in which liquid does the body experience, not temperature, the body experience the greatest buoyant force? Second is which liquid has the least density, and C, which liquid has the highest density. See, in the three cases, in the three liquids, the body is floating. Okay, so what happens as the body is floating? So the buoyant force in all the three liquids will be the same. Okay, it's floating. So but in each case, in the liquid A, the body is the body which is floating, it has 3/4 of the body underwater. Okay, in the B, half of the body is underwater, and in case of C, 1/4 of the body is underwater. So but in all the cases the body is floating, it's not sinking. So the buoyant force will be equal. Okay, now which liquid has the least density? The liquid A has the least density, because see, this body is 3/4 part is sinking inside the body, is inside the liquid A. Okay, and the least density is the highest density is liquid C, in which the body is 1/4 of the body part, with its 1/4 of the body part is floating. It's floating with its 1/4 of the body part immersed inside the liquid. Okay, so this is the case. Now we come to 20th number of question. For a floating body, how is its weight related to the buoyant force? The weight of the body is equal to the buoyant force. Okay, the weight of the body is equal to the buoyant force. In this case, the body will float just inside the surface of the liquid. Okay, and the weight of the body is less than the buoyant force. In this case, what happens? The body will float partially above the surface of the liquid. Okay, so what happens? See, in this case, it is telling that the weight of the body is equal to the buoyant force. Okay, in this case, what happens? The body floats just inside, just below the surface of the liquid. Okay. And in the second case, what happens? The weight of the body is less than the buoyant force, where you can see that it's floating partially above the surface of the liquid, slightly above the surface of the liquid. In the above case, that is in the question number 19, we see in all the three cases the body is floating partially above the liquid. Okay, that is some part of the body is still inside the liquid. That's why the buoyant force in the three cases will be equal. Okay. Next we come to 21st question. Why does a piece of ice float on water? Because the density of ice is 0.9 grams per centimeter cube, or you can say 900 kg per meter cube, while the density of water is 1 gram per centimeter cube, or 1000 kg per meter cube. Therefore, the density of ice is less than that of the water. That's why it's floating. Then explain why an iron needle sinks in water, but a ship made of iron floats on water. Because a needle is a solid. Okay, and it's a solid iron, that is, you can say, and the density of iron is greater than that of the water. Okay, so the weight of the needle is more than the buoyant force of the water on it, so it sinks. So the needle sinks in water. But in case of ship, what happens? In case of ship, the ship is hollow and its empty space contains air. Okay, and this makes the average density of this ship less than that of the water. That's why a ship floats on water. Okay. Now it is easier to swim in sea water than a river water. Explain the reason. Because sea water contains salt, so its density is more than the density of river water. The weight of a man gets balanced by the less immersed part of his body in the sea water as compared to the river water. River water, his body sinks more, but in sea water, his body does not sink more, rather floats. More of the body part floats in the sea water. That's why it's easier to swim in the sea water. Okay. Iceberg float on sea water are dangerous for the ships. Okay. Explain the reason. Because the density of ice is less than the density of sea water. And the density of ice is 0.9 grams per centimeter cube, and the density of sea water is 1.02 grams per centimeter cube. Therefore, an iceberg floats in sea water with its large portion submerged inside the water, and only a little portion is above it, above the surface of the water. So, a ship can collide with the invisible part of this iceberg under the seawater. You cannot see the iceberg which is under the water. Large part of it is underwater, and that is not visible to the ship. Therefore, it can collide with that part. That is why it's dangerous for the ships. Now, explain why it is easier to lift a stone underwater than in air. Because in water, it experiences an upward buoyant force. When this stone is underwater, it experiences a buoyant force which is balancing the actual weight of the stone, which is acting downwards. That is, the actual weight of the stone is acting downwards, and there is a buoyant force which is pulling it up, pushing it up. Therefore, that weight is balanced, and therefore, what happens due to this upthrust? There is an apparent loss in weight of the heavy stone, which makes it lighter in water, and hence it's easier to lift. This buoyant force acts both in air and water on everything, but because of water's density, the force is stronger in water than that is in air. Okay, because the water has is more denser than air, therefore it is the force is much stronger in water than that of air. Therefore, it is easier to lift a stone in water than it is in air. Now, what is a submarine, and how can it be made to dive in water and come to the surface of the water? A submarine. Okay, a submarine is a watertight boat which can travel underwater like a ship. It can travel under the water, okay, like a ship. It is provided with water tanks. And to make the submarine dive, the tanks are filled with water so that the average density of the submarine becomes greater than that of the sea water, and it sinks. And to make the submarine rise to the surface of water, these tanks are emptied. They push out the water. Okay, this makes the average density of the seawater more than the submarine, and the submarine rises up. Okay. Now, a balloon filled with hydrogen rises in air because, explain the reason. Okay. The reason is that the density of a gas is less than the density of air. Okay, this gas, that is the hydrogen gas, that density of this gas is less than the air, and so the buoyant force experienced by the balloon due to the air becomes greater than the weight of the balloon. Hence, the balloon rises up under the influence of the net upward force. Okay, you are provided with a glass stopper and a measuring cylinder. How will you proceed to find the density of the stopper? Okay, this is the repetition of the question number 7. See, in the question number 7, we have said that, just a minute, I'll tell you. See, in this way, how did we had measured the coin, no? Like that only. First, we should take the glass toppers weight by, the mass of the glass topper by a physical balance, and then for taking the volume of the glass topper, we first take a measuring cylinder in which we pour some water in it, and we note the initial level, and then we put the drop the glass stopper with a thread inside that measuring cylinder, and we see the water rising up to a certain level. Now we note down the final level. Okay, then we subtract from the final level, the initial level we subtracted, and that then we can get the volume of the stopper. Okay, and the density will be mass by volume. Okay, that will be the way in which we can find the density of the glass stopper. Okay. Now, this question, briefly describe how will you find experimentally the density of a kerosene oil with a density bottle. This is also the same as question number 9. Okay, in the first we take the density bottle, wash it, dry it first, then we measure it. Okay, take the weight, then take the mass of it with a physical balance, then we pour some water in it, and note down the mass, that is by weighing it in a physical balance, we can note down its mass. Okay, then we empty the bottle, then we again dry it, and we fill it with the kerosene oil. Okay, then we again note down the mass. So, and after then subtract it from the initial level, that is the, say, M3 is the kerosene oil mass, I mean M3 will be the density bottle with the kerosene oil mass, and this M2 will be the density of the, I mean the mass of the water with the density bottle. Like that we'll subtract. You please refer to question number 9, you can get the total answer about it. Okay, so I think I should stop here. I'll continue with the in my next video, the rest of the questions. Please go through this. If you have any doubt regarding any other questions or any other questions you want to discuss besides these questions, or any doubt regarding this chapter, you can please write down in my comment box, and for referring to the text videos, I'll give this link, the text video link, inside my description box. Okay, please refer to them. Hoping you are liking the videos, and if you are liking it, please do press the like button, and share with your friends so that they are also benefited by these videos. And if you are a new viewer to my channel, or not subscribed yet, please do subscribe to get the notification of my next video. Okay, thank you.